there is a fair amount of echo that we get from the room. I'm not sure whether that's anything that you guys can fix.
He did. I'm not sure what to do. I don't know what mics are on.
All right. Good morning. How is our echo sounding right now?
It sounds pretty good here.
Okay.
There's a little bit of echo, but I think it's manageable.
It's still there, but I think we can deal with it.
All right. I think we'll just go ahead then. If there are people on site with Meet Echo who can help keep tuning things, that would be wonderful. But otherwise, we'll forge ahead. All right. Let me turn on my video a bit. All right, hello from 2 a.m. in California. All right. Let's get started. So welcome officially to IETF 113 in Vienna and virtually. This is our first really hybrid meeting. And so we'll all be learning how to do this. So let's have a lot of patience and grace with each other in this. You are in IPPM, IP Performance Measurement. I am Tommy Foley, one of your chairs. Marcus, also here, probably more awake than me. And we have a pretty packed agenda today. Let's get started. First, if this is one of your first IETF meetings, or if it's your 30th, we do ask you to note well all of the different policies for participation and contribution in the IETF. If you haven't seen this before, please do take a moment to read through it. For the meeting management, for people both on-site and remote, we are using Meet Echo. Now it's the same way it's been working virtually for the people who are remote, and in person, I believe there is a Meet Echo mobile app that you can use for queuing. Please do use that. We can see the camera into the room, but it will be useful to manage everything through Meet Echo there. If you are presenting, you are able to share your own slides in the Meet Echo tool. Up at the top, there is the document view with a slash through it, and if you click on that, you should be able to ask to share slides. There should be an equivalent button in the mobile experience. If you need help sharing slides, the chairs can also do it for you. And then we do have notes going on. Thank you, Stuart, for taking the notes for this meeting. For Jabber scribing, I think the chairs right now can take care of Jabber, and we can also ask people in the room to relay things. All right, looking at our agenda, we are spending the first chunk on the primary working group documents that we have that are active. We have a bunch of documents that are in later stages. They're with the IESG, or they are in the RFC editor queue. We've been very productive, so thank you to everyone in the working group for that. But today we'll go through some of the protocols, starting with some of the more newly adopted protocol work, and then getting some updates on IOAM, as well as explicit flow measurements and SRPM. And then after that, we have some shorter talks about some new proposed work that has received either a lot of work on side meetings or discussion on the list. And that's all we have for today. Any agenda bashing, or should we launch right in? Okay. I think first up then we have our capacity metric protocol with Al. And Al, do you want to share the slides from your end?
Hi Tommy, if you guys can share the slides, that would help, I think.
Okay, I can do it. Again, it is available in the preloaded slides here, but we can.
Yeah, that's great.
All right.
And I'll share my video briefly. There I am in front of my quilt made of IETF t-shirts. Good morning, everybody. We've got the capacity measurement protocol to talk about this morning. We've got a working group draft and one which we've updated. Len Chavatone, my longtime colleague, and I are working on this together. We're looking for more help and review from the working group. So next slide, please. So here's a little reminder about the protocol. We've got basically a simple setup exchange between the client and the server, test activation exchange that follows that talks about the optional testing parameters. In this first phase, we've added server admission control, a kind of a programmed bandwidth check. And we think that'll help with managing the server capacity. And the rest of after the test exchange, setup exchange and test activation exchange takes place, we have the test stream, and that still has a feedback path with the either the measurements or the commanded test rates to use for the next 50 milliseconds or so. So we've got a continued round-trip relationship going on throughout the operation of the protocol. And we actually set bits in the load PDUs to stop the test, stop 1 and stop 2 from the server and client respectively. And so that's how we basically turn things down at the end of the test duration. Next slide, please. So thanks for working group adoption. Some new folks joined the working group based on the work in the open source project, and it was good to have their input and review all along the way. In fact, they've continued to make good suggestions, like the suggestion to include a randomized payload option, and also how that might be implemented. So we've tested the performance of that, and the code suggests performance of the code. It suggests very little compressibility of the packet payloads. So that's good. In fact, we got surprisingly low rates in some of the tests where much higher rates were claimed. So, and as I mentioned, the server can set a bandwidth limit for admission control. That's great when you have some clients trying to test 5 gigabit per second services and some clients trying to test 25 megabit per second services. You don't have to allocate 5 gigabits to everybody. Big savings there. We have an optional start rate in the load adjustment algorithm now. The fixed rate option remains. So that basically means that if you're trying to achieve gigabit rates, you might start at 500 megabits and search your way up from there. Also, we've got backward compatibility. The new version 9 of the protocol, which is in the draft, is backward compatible with version 8, which was present up till the last version, working group 00. And we got some good feedback from folks during working group adoption. One of the points was consistent terms for test activation and question response. That came from Rudiger Guide. Also, the clarifications about test stop. And there are even more error codes now. So we're keeping the field bite-sized, and a bitmap would be much bigger, I think, if we tried to implement that. And in section 4, I took out all the parameters that were basically referred to or were redundant with RFC 9097, the metric and method. And we've basically trimmed down our proposal to 4 security modes. The 2 that we've got implemented, unauthenticated and password, and we've got a secure setup exchange, so that would just be the first part of the setup. And then, the classic secure all the things, that's the last proposal. So we'll talk more about that in a moment. Next slide, please. Okay, so the next steps, authors welcome proposals and revisions to the security modes. With working group adoption, we can now adopt or ask for an early sector review. May help us solve that in one go, and that would be really cool. As we've learned in past meetings, there's no silver bullet, but maybe if we make this simple, we can get a good simple answer and be done. So obviously, one of the things I talked about last time back in November was that this protocol can do more than measure capacity. We've got the ability to have real-time feedbacks of measurements, and you can actually do a lot with that. Change the sending rates as we do now, but that could be as a result of other paradigms or heuristics that people want to use in order to model traffic. I mentioned the 4 modes. If you want more modes, say so. And Protocol 9 allows for a new load adjustment algorithm with more robustness to all sorts of problems. Because the feedback we got is people said, look, you guys say you're measuring maximum capacity, so please always do that. Even if you have to put more load in the channel, do it. So that's what we heard, and that's what we're working on. So I got 3 minutes to let people ask questions. Thanks.
All right. Frank, were you in the queue, or are you?
I'm trying to go and understand how to queue.
Yeah, you are able to unmute yourself. You can also click the hand, but it's fine. Go ahead, please.
Okay, I have a very simple question to Al. So, Al, you mentioned that there is an open source implementation. Could you drop us a pointer to that one?
Yeah, of course, Frank.
And maybe add a reference. So I'd be, I might have somebody that wants to go and use it.
Yeah, cool. I think it's in the draft, and
I didn't find it in the draft, which is why I'm asking. So, but maybe I just didn't read it carefully enough.
Oh, okay. All right. I'll drop it in the meeting minutes, and so it'll be there. But it's an open broadband project on GitHub.
So it's open broadband. Okay, then it's the UDP ST reference. Okay, got it. Thank you.
Yeah, good. I'll go back and put it in the notes.
All right. Will, were you trying to get in queue or no? Okay, cool. Thank you. All right. Any other questions
Next
for
presentation.
Al?
Thanks.
Okay, I'm not seeing anyone else get in queue. Thank you, Al, for this. So it sounds like there are a couple actions that the chairs have. So if we could add that to the notes, that we should be asking for the early sector review, and we can kick that off soon. And then also for the repository for the code, we actually have a new tag and data tracker for related implementations so that you can find it more easily, and we can make sure that can get added as well, so that when people look at the document and data tracker, they can just click on a link and see your implementation. So thank you.
Cool.
All right. I think next up we have responsiveness. And Christoph, did you want to be able to drive the slides for yourself there?
Yes, I can do that.
Great, thank you.
Yeah. Let's show my screen. Sorry about that. Okay. Hello, everyone. I hope you can see my slides being presented. Yes. Okay. So, welcome. This is responsiveness under working conditions. I am going to present the changes that have been happening in the draft and the main discussions points that were happening during the working group adoption. But before I go into the draft, I have two parts of the presentation. One that is on the implementation experience. The first one is on the server side. We have open source implementations of the server side. And the second one is we have a new open source client-side implementation that implements the methodology. So first I'll hand over the speaking to Randall about from Apple about the server side.
Hello. Hi. Hopefully it can be heard. It looks like it. Okay. Hi. At the network quality server repository, we have sample configurations for Apache Traffic Server, Apache HTTPD, and Nginx. In this same repo, there are two complete server implementations written in Swift and Go that can be used standalone from other web servers in front of them. The Apache Traffic Server configuration in that repo is the same implementation that Apple CDN uses to serve traffic for the network quality tool from Apple. Next, I'd like to introduce Will Hawkins of the University of Cincinnati. Take it away, Will.
Thanks. That was quick and succinct. I like that. Thank you, Randall. Well, my name is Will Hawkins. I'm from the University of Cincinnati, and I've been working with both Christoph and Randall for quite some time now on implementing the protocol in Go as a second the clean room implementation. And so I just wanted to report a little bit on that today. All of this code is out there right now on GitHub at the following URL, the URL you can screen. The license is under GPL version 3. It is
Gentlemen,
implemented.
Jen, we're having a little trouble in the room here with the slides aren't showing for some reason on the screen, and we're trying to diagnose that.
Let me,
Christoph, yeah, let's switch
Let
to
me see
the
if I-
preloaded slides.
Yeah.
Take off your screen.
This is
will you
much
share it
better.
or should I go ahead?
Yes, well, it's
you
coming up
please
now,
share.
so that's good.
Christoph, you should be granted, you should be able to see a way to
Yeah.
select which deck you want. Yeah, there you go.
Okay,
There
we
we
were
go.
seeing it now on our screen here.
Awesome. Okay.
Great. Sorry about that.
Yeah, I'm sorry. I hope I didn't screw anything up there. But the implementation is in Go, and it has been tested as far back as Go version 1.16. Presumably, it'll work with earlier versions. I just haven't tested with it. So, not that it won't work, but this is sort of our backwards version. So far, I wanted to report on interoperability successes. We have had successful interoperability with Apple's implementation, as Randall just talked about, the one that they did in Go. So we've had successful implementation, interoperation with that one, and also successful interoperation with Apple's public measurement endpoints that are out there, and are the same ones that are used by the macOS and iOS clients. The to-do on the interoperability right now is to do calibration of the RPM measurement between the network quality client that's in macOS and iOS and our version. So we're currently working on that. Just a few lessons learned before I turn it back over to Christoph. And one of the really important lessons that we learned was to ensure that Go's HTTP API opens HTTP2 connections. When we attempt to use some advanced configuration options on the HTTP API, it tends to default back to HTTP 1.1 connections. And we really want to make sure that that's 2.0. One of the other big lessons that we learned that took a long time to overcome is that Go's HTTP API aggressively pools TCP connections. So that prevents us from saturating the bandwidth in the way that we really want to be able to do saturation. Finally, one of the big lessons that we learned is to build in debugging support from the beginning. One of the things that the implementation has now is the ability to log per session SSL keys, which give you the option or the opportunity to use Wireshark to do debugging of connections and at the saturation as it goes. Finally, as usual with any implementation and interoperation test and work, is to take advantage of this experience to clarify ambiguities in the protocol and to get those rounded out. And that's one of the things that I think Christoph will talk about as he goes into talking about the protocol itself and the changes that we've made. So I don't want to steal his thunder, but feel free as we go forward at the end of the talk, if there's any questions, I would love to have those. And please feel free to reach out on GitHub and send patches or submit issues if you try it out. Thank you very much.
Yeah, thank you, Will. That was great. So over to the major changes in the IETF draft. Thank you very much for the working group adoption. So during this presentation, I want to address mostly the two biggest discussing points, which were around what is working conditions and how can we interpret responsiveness results. Additionally, there were, in terms of the changes to the draft, there were a lot of minor tweaks in the wording and clarifications. Thanks to many contributors, particularly Will also from his implementation experience, on to make things more clear on how the protocol actually works. So the first big discussion point was, what does it actually mean, working conditions? So in that sense, I clarified the definition of working conditions in the section, in the working conditions section. And so I want to revisit this here and open it up for any kind of discussions that may come up. So the goal of the working conditions, the way we define it, is to create a realistic traffic pattern that is exploring the worst case scenario. And that is an important definition in the sense that realistic means that we don't want to flood the network with, I don't know, UDP traffic, for example, because we are not trying to measure the maximum capacity like in the previous draft. We are trying to explore how the network behaves when it is under traffic patterns that end users actually generate. And so we use HTTP2 or HTTP3 in the future with standard congestion controls. That way we create the realistic part of the network responsiveness working condition. And how can we push it to the worst case scenario? It's by creating multiple bulk HTTP requests. Like now, what we want to do is in the responsiveness test is we want to expose any kind of buffer bloat, right? And a single TCP connection already would create the kind of buffer bloat that we need to measure it. However, a single connection with TCP's sawtooth would create only very temporary buffer bloat. However, we want to create what we call a stable buffer bloat situation so that we can actually measure it over a certain duration of time. And so we create this kind of stable buffer bloat situation by creating multiple HTTP requests. And so we literally push the network into a worst case scenario. But even by creating those multiple bulk HTTP requests, we remain as a realistic traffic pattern because it's very similar to basically when you receive a message or send an email with multiple large attachments, same scenario. So, are there any questions or comments on the working conditions? Okay, thanks. Then I move on to the next part. Another part of the discussions we had was about how to interpret responsiveness results and what are we actually measuring. So I mentioned earlier that we are trying to expose buffer bloat, and typically people look at buffer bloat as whatever is happening inside the routers and switches. Now, that is true, definitely, and each network point between a client and a server has the potential to expose buffer bloat and to have buffer bloat. However, buffer bloat can also happen in the end host stacks. The entire networking stack from IP all the way up to HTTP can be subject to buffer bloat. And so each of these points in the networking stack layer has the potential to create buffer bloat. And so because our methodology is using HTTP, we may expose these kind of buffer bloats as well. It can be argued whether that is intentional or not. And in our case, it actually is intentional, right? Because we want to measure responsiveness the way the end users are experiencing, we are intentionally using HTTP so that we are able to expose these kind of buffer bloats on the endpoint networking stacks. So one of the questions during the adoption call was, well, if I'm having, let's say, I'm measuring responsiveness and I create this load generating connection between the client and the server here in red, right? And it's filling the pipe and it is exposing buffer bloat on the right side, those blue boxes that I drew here. Let's say the buffer bloat is happening in these sections, the HTTP, the TLS, and the TCP connection. Now, as a measurement user, how would I be able to root cause it and to identify that the buffer bloat is happening there? Well, one way it is possible to do this is because we create not only responsiveness probes on the load generating connection, We also create separate connections to probe for responsiveness. And by using these separate connections, we are able to identify whether the buffer upload is happening deep inside the network or it is happening on an endpoint networking stack on the HTTP or TLS or TCP layer. So that with this explanation in the new section, Interpreting Responsiveness Results, I hope that I addressed all the comments around how we can root cause and understand the responsiveness results. So does anybody has any questions or suggestions around these, say, replies to the comments during the adoption call?
Yeah, so please get in the Meet Echo queue if you have any questions. Ignacio, I do see that you have some comments or questions on the chat. Be happy to hear those as well. And Stuart is in the queue.
Look at the chat.
So I assume I'm doing this right. I click the button on my laptop and I'm coming to the microphone. Yeah. Yes. Okay.
You're good.
Okay. I just wanted to thank William for getting involved with this and doing the clients in Go. I think that's awesome. So thank you for that contribution.
Yeah, it came through.
And I see, thanks Stuart, I also see there's a comment on the chat. How do we intend to create real traffic? So the real traffic is by, we create HTTP bulk data transfers. So we do an HTTP GET for a very large file. And depending on the server implementation, we actually recommend this large file to be basically an infinite response. And so that is our way to create a real traffic, because HTTP GETs for large file is what happens when you are downloading a large attachment from an email. And so this is, as far as we see, the closest we can get to a realistic traffic pattern.
All right. And then, Mr. Ignacio, do you want to unmute yourself? Thank you. Thank you.
Hi, everybody. Can you hear me? Okay. My question is related to, because normally the real traffic inside of a network depends not just in one client, it depends on several clients, multiple clients. And this is the part which is real difficult to imitate. Imagine that you are behind a network and then, okay, it's not so clear in the literature, but normally it depends on the loop of TCP, for instance, when some packet is dropped, something like that. This is the idea about the question. How do you plan to imitate this large amount of clients doing traffic at the same time? Thank you.
Thank you for this question. So I agree, that's imitating multiple different clients. And if I say clients, I mean different different devices is unfortunately not possible with this kind of a test. We would need to have some inter-device synchronization and communication to start the test, and then have them all create these kind of HTTP bulk data transfers at the same time. And doing that is not possible without a protocol to talk between the devices. And it's, from our perspective, currently out of scope for this draft to do this. For now, we are targeting only load that is generated by the device itself. You had a second question around TCP and how it reacts to how it reacts to the packet loss and so on. That is the reason why we create multiple TCP connections, so that we can, when one TCP experiences a packet loss, the other one is still going and sending at full speed.
All right, and we have Al in the queue. Go ahead.
Okay, thanks. Thanks for your updated draft, Christoph, and to everyone for your work in implementation. A couple of questions to your summary, trying to close the discussion on working load and responsiveness here. I noted, I read the draft again yesterday quickly, and I noted sort of the use of capacity alongside, the capacity of the link alongside words like saturation, and then, the real test is based on TCP maximum good put. So, I mean, there's still, obviously some different terms and some different ways to interpret what the working load conditions could be. For example, we're in the metric and method that the protocol I just talked about supports. That's a maximum IP layer capacity. So there's still, I think, a little ambiguity in the terminology that you might be able to root out. Also, I didn't notice in the draft any discussion of the effects of congestion control algorithms. The sort of the older ones are more likely to fill the buffers, and some of the newer ones have the goal of not doing that. So you're going to get different levels of working conditions from those, and as Ignacio says, with multiple clients, you're going to get kind of a mixture of those congestion control algorithms potentially. So there's there's some things to talk about here, and unfortunately, I don't think we can shut the door on all these discussions quite yet. But thanks for putting your work together. Appreciate it.
Thanks a lot for your feedback, Al. Yeah, we'll definitely try to clean up some parts of the capacity wording, and I'll take your feedback and go another pass on capacity and the wording, making sure that we use the right terminologies there. And I like actually the suggestion around having a discussion around congestion controls. I'll add a subsection for that as well. Thanks.
All right, thank you. And I think we are up on time. Christoph, were you at the end of your slides?
Yes.
Okay. Well, thank you very much. And I believe next we have, Xiaomin. And are you able to drive the slides yourself, or do you want us to do that?
Would you help to share the slide?
I can.
Thank you.
I can do it. Let me find it. There you go.
Okay. Hello, everyone. It's Xiaomin speaking. This presentation is on echo request reply for enabled in-situ OEM capabilities. The latest version is 0.3. The last IETF, the 0.1 version, has been presented. Next slide, please. After IETF 112, 3 discussion points were raised and fully discussed on the mailing list. First one, is this document still needed in a limited domain? The quick answer is yes. Correspondingly, updates have been made in the introduction section to clarify its usage. Second discussion point is, may this document be obsoleted by a YAM model? The quick answer is no. Correspondingly, suggestion on using Icmp to carry YAM model is not accepted. The third discussion point is, are more requirements than recommendations needed for security? The quick answer is yes. And the requirements are specific to Icmp v6, etc. Clarifications have been made in the security considerations section of this draft. Next slide, please. This slide provides more details on discussion on point 1. In a limited domain as defined in RFC 8799, this document is not needed if both preconditions exist. The first one, a control entity that has control over every IOM device is deployed. The second one, a strict explicit path for the IOM packets is provisioned by the control entity. The takeaway from the discussion is that if neither of the above preconditions can be confirmed, then this document is still needed in a limited domain. Next slide, please. This slide provides more details on discussion point 2. During the first working group adoption poll of this draft, there was an older suggestion to use netconf between IOM encapsulating node and IOM transit decapsulating nodes. One paragraph was added into the introduction section to explain why it's not a preferred approach. After that, there was a later suggestion to use Icmp to carry the informational elements derived from the YAM model. However, echo request reply is not a management protocol like netconf or restconf. Icmp doesn't seem suitable for carrying informational elements derived from the YAM model. So this latest suggestion is not accepted. Next slide, please. This slide provides more details on discussion point 3. A number of specific security requirements for Icmp v6 are defined in the Icmp v6 extension draft. The enforcement of these security methods might be discussed and recorded in that draft. So here we list all the security methods. First one, we can use IP authentication header or IP encapsulating security payload header to provide integrity protection for the IAM capabilities information. We can also use IP encapsulating security payload header to provide privacy protection. And network operators can establish policies that restrict access to the Icmp v6 IOM echo functionality. They can enable, disable Icmp v6 IOM echo functionality. They can define enabled namespace IDs. They can do for each enable the namespace ID define the prefix from which ICMPv6 IOM echo request messages are acceptable. And last one, rate limit incoming ICMPv6 IOM echo request messages is also a method for the security mitigation. Next slide, please. A few other updates have been made since IETF 112. First change is on tracing capabilities objects, including pre-allocated tracing and incremental tracing. Egress MTU and egress interface ID are substituted by ingress MTU and ingress interface ID. Because ICMPv6 echo request is destined for the responding node itself. The last two changes are on POT, proof of transit capabilities object and edge-to-edge capabilities object, respectively. They are aimed to align with the latest IOM data draft. Next slide, please. The authors believe this draft is ready for working group last call. So we kindly request the working group chairs to issue working group last call on this draft. That's all. Thank you.
All right, thank you. Do we have any comments, questions? Does anyone in the room have any concerns with going to working group last call on this relatively soon? All right, I'm not seeing anyone come into the queue. So we can, the chairs will discuss and then get back to you on that.
Okay, thank you. Thank you, Tommy.
Thank you. All right. Then next up, I believe we have Frank covering a couple documents on IOM as well. Or Justin. Oh, sorry, my bad.
Yeah, can you hear me?
Yep.
All right. I tried to share the slides.
It's a little bit quiet for the remote
Yeah,
folks,
I don't
but
think my mic is working actually. Is this one working?
that one is better. Yeah, so let's use that one.
Yeah, all right. Still this one. So I'll go first, and then Frank will provide the update on the deployment draft. So about the data integrity, we have clarified the scope of the document. So basically, now the integrity protection is on IOM data fields and not including headers for obvious reasons we have shared on the mailing list. And as a consequence, the algorithms were returned to be more generic, and so they work for currently defined IOM option types, and so for future defining. And also as a direct consequence, the direct export option type is not included anymore because it doesn't fit. Because if you see the defining of such option type, it doesn't contain any IOM data field per se. Okay, so if you really want to go that way and have header protection, I think we could have a per hop verification, but not sure if you want to go that way. So we can discuss that later on the mailing list. And so the update also includes some editorial changes. We have used the IOM data fields notation that is defined in the IOM data draft to keep it consistent. And some structure, or some section and subsections were restructured also. So if you can review it and provide some feedback, it would be greatly appreciated. And Tommy, I don't know if you want to take questions now for this draft or if we do it for both after Frank.
Sure. If there are any questions on this document, we can take them now. I don't know if anyone has any. I guess just for myself, for getting further reviews, do we want to ask for any particular external reviews, sector reviews, etc.? Who are we asking? Are we asking people inside the working group? Are we asking people outside?
Yeah, I think the main objective was that given that this document is really a document that was inspired by the working group originally, right? Where people said, well, yeah, well, even though we're in a limited domain, we do want to have a dedicated way to go and ensure integrity above and beyond what you can go and do with the underlying transport if you're writing on top of, say, V6 and would be able to use authentication headers and the likes. And so we would really appreciate hearing back from people that were originally driving the questions, whether the document in its current shape actually meets what they had in mind. I think that's more like what we were asking this review to be, so that we at some point can call the document done and then progress.
Okay.
I think it's not so much of a security review, because I think the methods that we are using are well known and state of the art. There's nothing really new or inventive here. It's more like applying known art to the problem. But let's see whether people consider that is usable, useful in the context of the original problem that people had in mind.
Got it. All right, sounds good. And yeah, just let us know if you want help soliciting feedback. All right. I don't see anyone else in the queue, so let's move forward.
Yeah, the next one is even faster. The next one is my bad, right? So the document's been pretty stable. We've not really heard anything back. And sorry, Jaumin, I forgot to add the beer reference, or not, I didn't forget to add the beer reference. I forgot to publish the draft, the 01 version before the cutoff. So which is why I added the GitHub reference. I'll push that out today, or if we get more feedback during the week, maybe towards the end of the week, early next week. If there is more things that people want or have experiences with from an IOM deployment perspective that they want to go and see represented in the draft, I want to go and keep it rolling for a while. We could go for last call, but I do think that, if we mature it over the course of another 2 or 3 IETF meetings, it might help everybody, given that it should go and aggregate all deployment experiences that we have with IOM. And thanks to Justin for coming up with an even more mature implementation in the kernel. And we also have an update on VPP. So maybe we get more experience with even the open source implementations, and we can go and fold that in. But for now, I've not really heard anything back. So keep feedback coming to the list or, the implementers. Thank you.
All right, thank you. Any questions on
this? Give you 9 minutes back.
That's fantastic. We will take it any day. All right. Thanks so much.
Thank you.
All right, and next we have IOM Yang, I believe. All right. Chandran, do you want to share your slides, or do you want help with that?
Could you please help to share the slides?
Okay.
Thanks. Great. In this presentation, we will report the major changes since the last meeting. Next. We adjust the comments from homepage and the requirements of the list. Firstly, we add some detailed parameters like timestamp type and available interface to IOM info. The IOM info is a container for all the read-only system information. So that monitoring system can interpret the IOM data. And secondly, we aligned with the latest IOM data draft on port configuration. User need to augment this module for the configuration of a specific port type. And then some YAM module issues. We reduced all the prefix YAM identifiers, add more descriptions and make the draft more readable, and updated the security considerations and cleaned some nits. And next. The IOM data plane drafts are stable, and this YAM module is already aligned, stable, and mature. So we would like to ask for YAM doctor review and also working group last call. Any questions, comments?
All right, I'm not seeing anyone queue up. If we could get in the notes the request to kick off the Yang Doctor review, the chairs can request that then.
Yes, thanks.
Okay. All right, if there are no comments or questions on this, I think we have a little bit of time back again. Thank you, and yeah, it's good to see this update and get this moving along. Thank you. All right. And then next up, we should have the explicit flow measurements document. All right, and will that be Mauro presenting? Great.
Okay. Can you hear me?
Yes, we can.
Okay.
I can't see your slides yet.
Okay.
You have to pick which deck you want, which deck you need.
It's from this. Okay. Share.
There you go.
Thank you to all. We can start. Okay. Change slide. Okay. Okay, can I resume briefly the topic of this draft? The species flow measurement are measurement made using real traffic, not artificial traffic. We can mark 1 or 2 bits or 3 in some cases for different measurement. The measurement that are in the draft are the round trip time. A new version of the round trip time measurement is the delay bit with the hidden bit option. That is an option that permits to save the privacy of the users. The round trip packet loss, one bit that permit to have a new measurement that is quite strange because we have a round trip packet loss, not a unidirectional packet loss. In this case, we have the measurement of all the packets from one side and a percentage of the package from the side with more packets. And a one-way packet loss that are made in the best options, in our opinion, using 2 bits. The square bit that is common to the two options that we can have for this measurement, and 2 different bits for the second part of the measurement, the loss event bit and the reflection square bit. Okay, the number of groups and companies that works about this topic is incremented from last time because the University of Technion, Israel Institute of Technology, joined us in this kind of work, and in particular Giuseppe Fioccola from Huawei managed the contact with this Institute of Research. So we are 3 different research groups that explore this kind of methodology for measurement in the network. So this is the hidden bit. This is the last addition to the draft as methodology. Draft updates. So in this meeting, we don't present a draft updates because we are waiting the very extensive revision that Ike Kunz from Aachen University terminate only last Thursday. And so we are waiting this revision. I thanks Ike Kunz for his work and the work of his research group in the university because he implemented all the algorithm described in this draft. So we have a new implementation, totally separate from the others. So he tested also the clarity of the description of the algorithm, and he suggested some updated. The main two is about the TB description, the round trip packet loss, because he asked to clarify better the token mechanism that maintains the throughput of the measurement equal in the two directions. The discussion about the trade-off of the duration of the measurement, because if the measurement, the period of the measurement is long, we have less measurement, and is short, we measure less packets for the packet loss. So there is a trade-off. There is a little bit discussion that is better to describe in the draft. There are other minor changes that he requested. One about a corner case in the reflection bit, and some editorial changes. We introduced this change in the next days, and we publish the draft when reopen the publication. This is the summary for the delay bit, the bit that are used to measure the delay and the round trip. And this is the summary of the measurement about the packet loss. There are many options. It depends from the protocol. For example, some protocol have only 2 bits, so only 1 bit can be used for packet loss. This is a little bit a problem because of 1 bit, the measurements are less precise. For the delay, 1 bit is sufficient because both spin bit and delay bit, also in the hidden version, needs only 1 bit. With 3 bit, it's possible to have 1 bit for loss, 1 bit for delay, and 2 bit for loss. This is all the options that we think that are quite interesting. So the conclusion is there are quite a big work about this topic. There are some sibling draft in the PPM working group, one in particular, that is about putting the probe not in the network as we thought at the beginning of the work, but also in the end user device in order to have an end-to-end measurement in a very simple way, also for methodology like qubit that is not an end-to-end methodology. So it's very convenient and it's possible to measure end-to-end, and combining this measurement with probe in the network is possible to split the measurement and to locate the problem if there is. Other sibling drafts are presented in other working group, in the co-op working group, in particular the last one. In the past was presented in Quick working group, and there are one draft also in TCP, a proposal. So we think that we are quite ready. I don't know if you are agree for the working group last call. In the end of the presentation, there is a summary of that is not a summary of all the authors of the working group, excuse me, of the draft, but only our company, Fabio Bulgarella, Massimo Nilo, and I suggested some possibility in case of the more common protocol for co-AAP with 2-bit to use the S-bit, the spin bit for RTT and RT packet loss for qubit, the qubit for RT packet loss. And for Quick, the preferred option was, in our opinion, the delay bit, also in the hidden bit version, but naturally also the spin bit is quite good. The delay bit has some advantage as we speak about in the draft. For the TCP, there is, in our opinion, a little bit difference about the packet loss, because for Quick we prefer qubit and L-bit. For TCP, qubit and R-bit, because the L-bit is a simpler implementation and there is less measurement delay. The R-bit detects these losses also for all ACK TCP packets, and is a protocol independent, so it not depends from the implementation of the protocol. So there are strengths and weaknesses in the both, but in our opinion, for Quick is better L-bit as second host bit, for TCP is better R-bit. But this is only a personal opinion of a subset of the working group about, not working group, draft group about this draft. Thank you. There are some questions and so on. We are.
All right, do we have any questions, thoughts on this? Please join the queue. Not seeing anything immediately. One question I did have on the drafts in other working groups and the discussion for how to apply this. I think the one on Quick was a while ago, and in co-op that just happened. Is this something that looks like it will get adopted in any of these working groups? Are we going to see this progress or get used?
No, because we decided to start from IPPM, also with some chairs that are agree with this approach, and after we put this idea inside the specific protocol working group. For co-op, the draft is active. We presented in the last interim meeting where Giuseppe Fioccola presented. Is a quite good interest from the working group. For Quick, in particular, in past was presented some technologies, in particular for packet loss, but the draft didn't go ahead, so we start again from the beginning in the methodology group that we think the PPM is the right one to refine better these methodologies.
Yeah, I'm asking though, as we are maturing this, and I think we could look at doing a last call on it. Do we want to essentially publish this without any adopters necessarily, or if we had some adopter lined up, that we thought would come in relatively soon, then we could um, see if there's any feedback from that protocoler group before we kind of finalize and publish this document. But that's not necessary.
Okay, we have to present something in other groups, so but now we are presenting only in the co-op working group, because quick working group, I don't know if they are so much interested in the topic till now, but we can retry if
Understood.
you.
Understood. Well, maybe what we can do is, do a last call, get the feedback here, but then once that has wrapped up, at least send a note to Quick to say, hey, if you remember this from before, we have some updates. Did we have someone in queue for a moment? No. Okay. All right. That sounds good. Thank you.
Thank you to all.
All right, and I believe we have one last working group document presentation on SRPM. Rakesh, do you want to share your slides? Or do you want help doing that?
Let me see if I can do it.
There we go.
You see slides I'm sharing?
We can see them.
Okay, perfect. Hi everyone, my name is Rakesh Gandhi and I'm presenting the STAM extensions for SR Networks recent updates to this draft on behalf of the authors listed here. So the agenda, just the updates that we made in revision 03 recently. The STAM-based work that we're doing in other working groups, we just flash it and the next steps. So in the recent revision, we have updated the usage of D flag, the wrong destination flag, the destination with reply required or not required. So there is either 0 or 1. We added a sub TLV for SRV6. It's a structure sub TLV, and some small minor editorial changes. And we had no open issues currently. So the structure SRV6 segment list TLV basically identifies the structure of the 128-bit SRV6 seed. So 128 bits, some bits can be for the node, some for the function length, and some for the argument. So it just identifies that. This is in line with other drafts and RFCs for SRV6. So there is some work going on as well in other working group. The IPPM has done a great job with coming up with stamp, and there are some extensions. There is some work in Spring. There is also some enhanced SRPM draft as well in Spring, as well as for the work for pseudowire extension in MPLS working group. So we'll appreciate your review comments. So there is some interest to do the interop testing for the extension in this draft. So we are interested in early INA code points. So we'd like to make a request for that. Welcome your comments and suggestions on the draft. And that's all I have. Any comments, questions?
Xiaomin, go ahead.
Can you go to slide 5?
We hear you.
Hi, do you hear me?
Yep.
Rakesh? Yeah,
Yes.
please go to slide 5.
Yep.
I think the second document is not IETF document. It's an individual document, right?
Yes. Yeah, there is a typo. Sorry.
All right. Rakesh, for the IANA assignment, can you send a note to the chairs, an email to the chairs about that, or on the list?
Yep. I'll do that.
Great. Okay. Seems like we don't have any more comments or questions on this right now.
Thank you.
Okay. And at that point, I believe we are ready to move on to some of our proposed work. We're a little bit ahead of time, so that's good. And first up, I believe we should have Nalini.
Okay. Let's try this. Just speak close to the mic if you can.
All right.
Hello. Am I audible?
So it's pretty quiet.
Oh.
All right, grab the other mic.
Is this good?
All right, okay.
Okay. Thank you.
Yeah, speak up. Do you want me to share the slides?
Yeah.
Okay.
Don't be afraid to put it right up there. Just give the mic COVID.
Okay. So, thank you. Okay, so talking about PDM-V2. So we are on the O2 draft. Next slide, please. So we first presented it in IETF111, had a side meeting. We explained the concept over there. Then we presented it at 112 in the IPPM working group and had a side meeting where we explained our Linux implementation and how it's working. Recently, we have been working on the lightweight registration protocol, which is a sample protocol along with PDM-V2, where we try to authenticate, authorize, and generate a shared context for, well, with the primary secret, basically. So that's what we have been working on. Today morning we had another side meeting where we showed the recent progress in registration protocol. And yesterday we got a chance to present it at the hackathon as well. Next slide, please. So this is the summary of the registration protocol. We have a primary client, primary server, secondary client, secondary server architecture. And yeah, the draft mentions a rationale for it. This is a summary mentioned in our appendix. We give one possible way of registration protocol, and we keep the option open to enterprises to either use this or have their own registration protocol. So, well, there is a flow between primary client and the primary server where, well, this is the starting step which we call it a setup step where we try to negotiate the cipher suite, a common cipher suite, and in return, the primary server will respond with the cipher suite and also share its public key. Then this is the Hpk Chem Key Encapsulation mechanism where we do the chem and share the encapsulation, and the primary server will basically do a decap and generate the same secret on its side. After this step, we have a common shared context on both the sides, and the secret can be used to encrypt the PDM extension header. Well, this secret is later shared with the secondary server and the secondary clients. We had received some comments in the side meetings with sharing this secret with the secondary clients, and we had taken care of it by generating client-specific keys. So what primary client does is it generates the client-specific
Well,
keys.
please keep the mic up to your mouth.
Sorry. Okay.
Yeah, we can't hear you.
So what the primary client does is it generates the client-specific keys by doing a KDF with the info parameter as the client IP, and generates the specific client generates the specific secondary client keys. And for sharing all these keys, we are using TLS as a means. So yeah, this is a registration protocol which we have added in the draft as of now. And yesterday in the hackathon, we were discussing on how to add authentication and authorization, and we had a brief implementation of that as well. Today we'll be presenting it at the hack demo. So yeah, next slide. Yeah, so we would like to ask for working group adoption on this. Any questions?
All right, thank you for the presentation. Just
Thank you.
for the a question on my end, actually.
Yes.
Just since we're not there in person, I'm not there in person right now for the side meetings and the hackathon. How many people are you having at the side meetings and the hackathon projects? How many people are engaged on this right now?
Yeah, hi, this is Nolene. Let me help you guys. Maybe we have our team here. Maybe you can
Awesome.
you guys can all raise your hands. We have Tommaso, who's a cryptographer from University of Florence, and then we have Mike Ackerman, who is an enterprise who's been involved with us all along. And so I think at the hackathon, there were I think there were 50, 60 people at the hackathon itself that we presented to. And I think this side meeting, it was a little early in the morning, so we had a little less attendance than we would have wanted. But the other side meetings, I think in the first one we had at least, I will say 30, 40 people. Second one, maybe I think 20, including some very good cryptographers, because that's what we were concerned with. Is this is sensitive information. And Mike, I don't know if you want to come up and talk about the enterprise use of this. Oh, you're in the queue already?
He's in the queue. All right. Come on up, Mike.
Testing. This does not.
You
Is
can
this
hear
on?
I think use this one, Mike. Mike, use mine.
Mike, meet Mike. I'm Mike Ackerman. I'm with a large enterprise, and we're excited about the information that that PDM can provide for enterprises and anybody else that are going to be managing their IPv6 networks in the future. We also recognize that there'll be situations where this information needs to be encrypted in the EHs that it's residing in. So that's where PDM v2 comes into play. So we're excited about both these developments. And I'm going to add one more thing. This is a personal thought. I think that when we enterprises finally do get IPv6 networks, which we're dragging our heels on terribly on right now, that we will have other pieces of information in other extension headers, and I would not like to see a different solution for each one of those that we're going to deploy in the future. So those are my 3 points, and we're excited about this development. I hope it can continue.
Yeah, thank you so much, Mike. And one thing I know that I'm going to just put a boast out. Mike and I have been working with a lot of the federal government in the United States to help them do their IPv6 address planning, because IPv6 planning at enterprises has lagged a great deal. And we're hoping actually to get some of these federal agencies to talk next time. But we're working with at least 3 different agencies. These are like, I mean, if I gave you the 3-letter acronyms, you would recognize all of them, some of them worldwide, and I know they will need this. So, yeah.
Great. Al is in queue. Do you want to join? Thank you.
Tom, thanks, Nalini and Mike and your team for this. It seems to me that you guys were extremely lucky to get the original PDM through the IETF and approval without encryption. Just good timing, I guess. And in today's environment, it makes a lot more sense to have an encrypted version of it. So just offering my support for this direction. Draft a long time ago. I appreciate that they've got a lot of work to do here, and it should be interesting to see it completed. Thanks.
Thank you so much, Al.
All right, and Martin.
Martin Duke, Google, no hats on. Yeah, like encryption's good, so thank you. If we do adopt this, I think it would be a good idea to get really early sec area review of this. I don't know. I mean, you've mentioned some cryptographers a bunch. I don't know who those people are, but we should probably run this through sec area sooner rather than later.
Absolutely. Absolutely. Yeah.
Great. And that sounds good. I was thinking the same thing, that it would be something good to adopt and then get a very early sector review. The use of HPKE, I think is the right thing to do here, but having more eyes on it is always a good idea. All right, thank you so much for this presentation.
Thank you so much.
Okay, and next up we have Greg with a couple documents. Greg, do you want to
if you
share yourself?
Oh, much appreciated.
Okay, let me pull those up. All right, so we have a 15-minute slot, but we're going to go through 2 documents here.
Yes, thank you. So let's first start with a hybrid 2-step collection and transport method. And next slide, please. So what is the goal of this protocol? It's a method to collect and transport on-path telemetry information. It can equally be used in point-to-point or point-to-multipoint cases. And the point-to-multipoint cases is a tricky one because, as you understand, the replication of packets, if packet includes telemetry information, inherently leads to replication of upstream collected telemetry. In some environments, that is not a big concern, but some networks are, especially for the services that are premium service and use guarantees for like ultra reliable low latency services, that becomes challenging. By separating the moment of uh, originating or generating telemetry information from the collection and transport, uh, we can achieve more accurate measurements. It's a known fact that getting the timestamp is recommended at the moment of the physical start of the transmitting packet to minimize the variable delay. But especially in IP and IPv6 environment, the packet checksum needs to be recalculated once we change the content, once we write the time value. So the separation is a good technique to improve the accuracy of the measurement. Also, with the hybrid two-step, we are removing the limits of amount of information that can be collected for the monitored flow. So we know that even if the network uses jumper frames, that still puts some limits on the amount of information that can be carried embedded into this trigger packet. And also because this is a separate mechanism and the packets are not the data packets, the integrity protection can be applied to this information and without affecting the accuracy of the measurement. Because again, if we take a measurement and then we apply integrity protection, then it introduces variable delay. Next slide, please. So we use specially constructed messages that follow their trigger packet in a data flow. Another advantage of what can be seen as advantage of this method is that the collection can be done out of band. So which means that it follows their topological path but uses a different class of service, so not to use the same bandwidth allocated for the data flow that is monitored. And again, in many environments, in many cases, that would be advantageous because it would not use their premium bandwidth. Next slide, please. So this is their outline of their follow-up packet. We had discussions and we added some fields for ease of parsing. And it's expected that it's processed at their same nodes that are generating information. And each node, when it receives the trigger packet, originates information and holds it for, according to the local policy, for the follow-up packet. One of the options that it gives us is that we can export raw measurements for each trigger packet, or measurements can be statistically processed locally and then collected using their follow-up packet. Next slide, please. As mentioned, so we can authenticate their information collected on each node individually. Next slide. Hybrid two-step can be used as with IEM as another trace option, and so we're proposing to allocate appropriate flag so that in telemetry data profile field. Next slide, please. So this is a graphical representation of the protocol. We identify the trigger packet, transit ingress node originates the follow-up packet, and then each transit node adds more information. If the MTU is about to be exceeded, then it uses their encapsulation of preceding follow-up packet and generates additional packet. So, and then they arrive at the egress node. Next slide, please. So that was the case for point-to-point, and this diagram reflects the theory of operation for point-to-multipoint. And so because we identify the flow, we don't have to copy the packets, and their replication node only generates a new follow-up packet that collects telemetry information on downstream of their multicast tree. Next slide, please. And this is very interesting mode that was suggested by Pascal, so that it works upstream. And their follow-up packet is generated by egress node of their for the flow, and then is sent in return path, tracing the same path of the monitored flow to the ingress. So, which might be useful for cases when the ingress node needs to be aware of the performance and can influence the network by selecting certain scenarios. One of the possible scenarios was the wireless. So it's a discussion in reliable wireless communication. I think the next slide. So we welcome comments and we'll appreciate the consideration of the working group adoption.
All right, thank you. Any questions, comments, support for doing this? And people can please also send feedback to the list.
Okay, so let's go next presentation.
Let me find those. There we go.
Okay, so precision availability metrics for SLO governed end-to-end services, or services that have multiple SLOs. Next slide, please. This is not really a new document, as you see. So this is a merge of two documents that we've discussed over course of several meetings. Next slide, please. And so what is the precision availability metrics? It expresses availability of the service relative to the requirements that are expressed in SLO. And SLO as being the measurable performance that characterizes the service, and usually it might have as an optimal performance that is requested and a critical level that needs to be maintained. So the PAM, or precision availability metrics, can be used to determine the degree of compliance which is the service is delivered versus their contract between the operator and the client. It also can provide the service according to SLO, whether it's for accounting, and of course it's a billing, or continuously monitor the quality with which the service is delivered. So what we propose to include in this metrics. Next slide, please. So their key element is their time unit or PAM interval. And then we differentiate the error interval, the interval when their metrics exceeds the optimal thresholds predefined, and error-free interval when their performance is below optimal or better, not below, but below the threshold, so not exceeding their optimal thresholds, and there is no defect being detected. The time interval could be 1 second or 1 millisecond. With error errored interval, we can identify the severely errored interval. So, and define it. We propose to define it as an interval where their performance metric exceeded critical level previously predefined, or defect was detected. You can notice that severely errored interval is a subset of errored interval. So then, based on these definitions, we can introduce basic metrics such as errored interval count, error-free interval count, and severely errored count. So the violated packet can be counted by intervals often more meaningful. And that leads us to the definition of availability. So if we can go to the next slide, please. Based on counts, we can go to the timing. So the time since the last errored interval and mean time between and the number of packets since and mean number of packets, and analogous for the severe error interval. Next slide, please. So lengthy disruption can give us the state. If we have consecutive severe error interval, we can define this state as unavailability, and then unavailability state begins with the start of the first of 10 consecutive states. Similarly, if we have 10 consecutive states of non-CE, so which is an error-free or error interval, and that qualify, then we can say that we have a service availability state. Also, we can calculate the ratio of error availability intervals and severe error intervals. Next slide, please. So we identified the items for further discussion and future work that will be outside of the scope of this draft. And we welcome inputs and contributions and collaboration. And next slide, please. So welcome comments, discussion, and we think that as a merge of the work that's been discussed, we would like chairs to consider working group adoption.
All right. Thank you. And thank you for your work on merging this. I think that's become more clear, certainly, as part of that. Do we have any quick questions from this group? I don't see anyone in the queue. All right. Thank you, Greg, for both of those presentations. And
thank you.
Again, if you have comments or thoughts, please bring those to the mailing list.
Thank you.
All right. Then next up, we have the OTWAMP on lag document.
And I will present this.
Okay, thank you.
Okay, I will start. This topic we talk about performance stamp and T1 extensions. And next, a lag provides multiple physical links into a single logical link. Usually, sorry.
Gentlemen, your microphone was cutting out a little bit. If you could start again.
Usually,
I'm not hearing your audio coming through now. Let's try that again. All right. Shannon, do you want to try to send audio again? Or if you're not able to, if you could drop a note in the chat. Oh, here we go. I'm not able to hear you currently. I don't know if anyone else is.
Cannot hear it.
It's not only you, right? So we can't hear it, General.
Okay, great. Okay. All right. Maybe let's switch
can you
over
hear me
to.
now?
Oh, yes. Now I can hear you. Can I try again? Okay. It sounds like we're having issues. Frank, let's switch over to your documents, if that's okay. Let me approve that. There you go.
Yeah, so let me see when I can find the deck. All right, so this is not my document. This is about trying to understand whether we want to go and progress that work or not. It had its hype, and then it went a little stale because people were waiting for the data draft to mature. We have the data draft in the RFC editor queue right now, and we have two documents that people felt are important prior, and I want to go and understand whether we want to go and progress them or just kind of sunset them. The first one is on using either type a protocol identification to carry IOM data, and that is largely for protocols like GRE, or we can use that for Geneva as well. The second document is for raw export of IOM data. Take the IOM data blob and export it using IPFix. Very simple method to go and at least have one standard means to go and get the data out. So the two drafts are old, mature. Both of them started in 2018, and they've been tagging along. They expired at some point, and I kind of refreshed them just recently. First one is raw export. As I said, it just takes the IOM blob, encapsulates that into IPFix, and then ships it off. There's a few nuances that are being added, a few new data fields. We would not even need to go and do an RFC for that in order to go and get the additional code points, but I think it's better if we do it that way because that means people are aware of it and it's well documented how they want to go and be done. The second thing is the draft that Brian Weiss wrote originally. A couple of protocols use an either type to identify a particular header. Geneva is one, GRE is another example, and that can be used to carry IOM data fields. And people felt like this is a simple way, at least, to go and get V4 support for IOM. using a GRE header. If we want to go and get the work progressed on both ends, I think, yeah, well, we can need to go and decide on whether we want to have a simple means to go and export IOM data using IPFix. Mickey Spiegel's draft would be an option for that. I've not really seen anything else. I know that there is a load of proprietary versions coming out right now. So having one standard version I would see as beneficial, but that would require other people to be interested in it. And the same goes for Brian's draft. I've seen people wanted to use IOM with V4, and GRE I think is the only way to go and do it in a standard conformant way. If we want GRE, we need an either type. And if we want an either type, we at least need the document to be working group adopted and matured, so that based on that, the ISG could formally apply with IEEE for an either type. So I think the question is really here, adopt or sunset for both of them. And I would appreciate your feedback.
All right, we have our area director in the queue.
Martin Duke, Google. Can you explain the difference in the use case between raw export and direct export?
So raw export just tells or is a way to go and get the IOM data shipped using IPFix. So it's the IPFix kind of wrapping or the additional data fields that you need in IPFix, the code points to go and ship the data. Direct export is IOM information or flags that tell a node to go and extract the data and then eventually ship it. How it's been shipped, direct export doesn't tell you. Right, so direct export is about flags in IOM on the wire that tell a node what to do. Raw export is what wrapper you want to go. Well, some means in IPFix to go and get us a quote-unquote standardized effort to go and get data off the node.
Okay, so they're complementary. Thank you.
Okay.
All right, so I can go and send the question one more time to list, and we can go decide accordingly. Like as I said, I'm not the author of those two drafts, but I do see value. But I'm the only one that doesn't make sense.
Right. I guess as a follow-on to that, Frank, do you know if those authors are willing to carry on their work? Are they still willing to drive that?
Yeah,
or
I think
would that need
at least from Brian, I know that he retired at some point. Not sure. Right. And well, with Mickey, I pinged him, but he probably moved on to other topics of given that he switched companies and the likes, right?
Yeah. Okay. So yeah, let's raise this on the list, but it does seem like we would need both interest in someone to
exactly. And I heard feedback off list from L1 large service provider in Europe that had its interest in at least the raw export work. So maybe we can have other people speak up there. I'll raise it on the list. Thank you.
Right. Thank you, Frank. All right. Tianren, are we able to hear your audio now? Do you want to try talking again?
Yeah. Can you hear me? Can you hear me right now?
Yes, I can. Yes.
Oh, thank you. That's great. Let's do quick. This topic we talk about performance measurement on lag, including two drafts for STAMP and the T1 extensions. Lag provides mechanisms to combine multiple physical links into a single logical link. Usually, when forwarding traffic over lag, the hash-based mechanism is used to load balance the traffic across the lag member links. Link delay of each member links varies because of different transport paths. To provide low latency service for time-sensitive traffic, we need to explicitly steer the traffic across the lag member links based on the link delay, loss, and so on. That requires a solution to measure the performance metrics of every member link of lag. Existing active PM methods run a single test session over the aggregation without the knowledge of each member link. This will make it impossible to measure the performance of a given physical member link. The the measured metrics can only reflect the performance of one member link or an average of all the member links of the lag. To solve this, we followed the similar idea of RFC 7130, the BFD on lag. Next, please. And to measure the performance metrics of every member link of a lag, multiple sections need to be established between the two endpoints that are connected by the lag. These sessions are called micro sessions. The micro sessions need to associate with the corresponding member links. For example, when the reflector receives a test packet, it needs to know from which member link the packet is received and correlate it with a micro session. So we extend a new command type to indicate the set of microsessions of a lag and use identifiers to correlate the test packet to a particular microsession and carry the member link information for a validity check. Next. This shows the OAMP and the TWAMP extensions, including control message and test packet. We add two new control messages, the request OAMP microsessions and the request TWAMP microsessions. And in the test packet, we add sender microsession ID and the reflector microsession ID. Both IDs are locally assigned. And next. And this shows the location of sender microsession ID and the reflector microsession ID in the authenticated mode. And next. Stamp do not have a control plan, so only need to extend the test packet. Stamp TLV mechanism extend stamp test packets with one or more optional TLVs. So we proposed a microsession ID TLV like this. And next. There are many suggestions in the mailing list. We all adjusted them in the latest version. And next. So more comments are welcome, and we believe both drafts are mature to be adopted by the working group. Thanks.
Okay, thank you. Any questions, comments, support? Please get in the queue if you have thoughts on this. Okay, sounds like we can probably take it back to the list, but thank you for this update.
Thank you.
All right, and with that, we are at the end of our agenda. So thank you all. I think we got through a lot of good progress on this. Thanks to all the authors. Marcus, anything from your end? Comments?
No, thanks everyone. Great agenda.
Oh, and thank you to Stuart for taking the notes. Much appreciated. All right. Great. Well, have a great IETF week, everyone, whether you are in Vienna or virtual. Take care.
I think we're the one that took care of this. Probably. So I think the draft is entering what we call last call, but the date is near, so basically those are the code points.